Okay, so we're going to look at applications of linear equations, basically, that come up in the LANTITE test. And the way that we can do that is we can just look at the structure of a linear equation in a really, really simple way. It generally works for almost every single application. So we can think of it as some total value, might actually put value in there, some total value is equal to either initial or a fixed value. So initial meaning a value that is paid or occurs first. And then a fixed value, that may be the other alternative. That may make more sense for the scenario. And that would be something that occurs only once when we say fixed. And then plus some rate here in blue. And generally an easy way to tell if you've got a rate is it'll have the word per in the units, kilometers per hour, dollars per kilo, that kind of thing. And then times by a number of uses. And it's effectively just following the linear equation format y equals c plus m x, and the idea is that x is the number of uses, and then c here is our fixed value, m is our gradient, and then y is the variable that we're trying to generally calculate. And so if we look at this example from the ACER practice material, we can use this trick to kind of speed up the answering of the question. So they've given us a number of different joining and monthly fees for different levels at a gym. And it says, what's the total cost for the first year of a silver membership? So this one's kind of setting you up for it, right? So we'd go to silver, obviously, and well, this one's a bit more logical. We'd have to pay the joining fee, and then we'd pay the $20 for that first month, right? Although, actually, I should read that properly. So for the first year, 12 of those, right? So each month we're going to pay $20. So putting it together, logically, you would think, well, 40 plus 20 lots of 12. And so when we do that, and obviously you could potentially use the calculator on this one as well if it's available to you. So here we get 240, and therefore it's going to cost $280 for the full year. And then that's the answer. If we come to the second one, it's asking you to derive a formula. And so even though you could probably look at this and just say, well, okay, well, 40 was the joining fee, 20 was the monthly fee, and just replace them right there, and 12 is the number of months. We can also use this structure here. So we can ask ourselves, well, first of all, which one was the initial or the fixed value? So the thing that's only paid once, is it the joining fee or is it the monthly fee? Clearly, you would only pay once. Once you've joined, that's all you need. So this here is going to be like the C value, our fixed fee. And then the rate is the monthly, because that would be dollars per month. And we get that word per in there, right? And so this here would be like our M, or our rate or gradient. And so putting that together into words, the equation for the total cost for some number of months would be the joining fee plus the rate, I'll just put monthly. And then you can see we times that by the number of uses over here. And the number of uses in this case is going to be the number of months, right? So I write this in a way that's kind of generalized so that it works for any scenario. In this case, we're using the monthly fee for n months for the equation there, right? So we'll just put n because we don't have a known number. And that then points us to the answer, right? So joining fee plus monthly fee times n, and we can see B is going to be the most correct. Now look out for C, it's got brackets around these two. And so using BODMAS, which we can probably go through in another video, that would be prioritizing the addition of the joining fee and the monthly fee, putting them into brackets. So C is not quite correct. The answer will be B. So in the final one, it just says Sam is considering joining the gym and paying for a 3-month membership. How much more would Sam pay at gold level compared to basic level? So what they're asking us to do here is effectively use our equation now. So let's write that down, right? So we've got the total cost is equal to, so this is our fixed fee, or our fixed value. So this is the joining fee. This is just from question 2, basically, plus then our monthly fee times by the number of months. And we're just going to do that for each of the gold level and then at the basic level. And it's asking us how much more would Sam pay. So we're looking for the difference, and difference just means to subtract. So let's do the gold one first, right? So the cost there is going to be equal to, so the joining fee on the gold is $50 and the monthly fee is $25. So we can create the gold equation, so to speak, like that. And we're going to do this for 3 months. So 50 plus 25 times 3. So that gives us 50 plus 75, following our BODMAS, and then $125. If we do that then for the basic plan, we do the same thing. So the cost is equal to, we'll have different joining and monthly fees. So now the joining fee here, the basic is $20 and the monthly is $10. So that will be 20 plus 10, and there's the equation. And then again, we can put the 3 in for 3 months. That'll then give us $30 there, 10 times 3, and 20 plus 30 is going to give us $50. And so finally, how much more is going to be just the difference between them. That's a little bit messy. And so that will be 125, take away 50, and so that's going to give us $75 more is how much you would pay on the gold level compared to the basic level. And that's it. So when we go through it, you can see whenever you get a question about linear or straight lines, constant gradients or constant rates, we can use this particular structure. You should be able to build equations from that. It makes it a whole lot easier to identify your fixed value and your rate value. You build the equation, and then from there, they're effectively just going to ask you to use the equation, meaning sub in values for the number of uses, like we did there. They may ask you to sub in a number here and solve, but it's a little bit less likely from ACER. They generally look at just evaluation, not solving and rearranging.